the next one, which is says integrate to approximate the normal annual. Again, this word now is annual. Now, if we didn't use integration, how else would we do this? Well, we'd have to go back, and remember our function is telling us the normal monthly, and so we'd have to say, okay, when t is 1, what's the monthly one? We can find that. When t is 2, what's that? T3, T4, January through December, and then we would have to add them up to come up with the normal annual rainfall. Not an impossible task. We can do that. But can we use our integration to do this? Well, if we're going to integrate, we're going to integrate from, let's say, 0 to 12. And we're going to integrate for our function, dt. This is going to be the integration from 0 to 12 of our function. I'm going to break it up into 3.121 dt plus the integration from 0 to 12 of the 2.399 and then the sine of 0.524t plus 1.377 dt. We'll break it up in that respect. Now the first one is going to be pretty straightforward. That one again is simply going to be 3.121t. Over here though is where we have, first of all, we have a scalar we can look at, but we have a composite function, the sign of another function here. So for this portion of it, let's let u equal, so let u equal the 0.524t plus 1.377. We'll integrate, or take the derivative rather, du dx as 0.524, and then du would be 0.524 dx, and of course then we can write this as 1 divided by 0.524 du equals dx. So if we take a look at this problem, again, the first part's going to be relatively easy. It's going to be 3.121t, so we'll just kind of leave that portion alone. And then we'll do our first substitution. And, oh, by the way, we have to integrate that from 0 to 12. But our next substitution then, I'm going to pull out that 2.399 before I start. I'm going to leave these empty for now. And this would give me the sine of u times 1 divided by 0.524 du. So let's keep that work straight here. That's off to the side there. We again would have our 3.121t integrating from 0 to 12. And we would have then 2.399 divided by 0.524. And we need to go back then and look at what is the sine of u. What's the integration of the sine of u? Well, again, what function would give us the derivative of sine u, and that would be negative cosine u. And we would integrate then this piece from, whatever those boundaries are. Let's do our second substitution so we can get back into terms of t. So we have 3.121t integrating from 0 to 12 plus, for now, 2.399 divided by 0.524 4, and I'm going to pull that negative. We can put that negative out here. And this is going to be cosine of, and u is again 0.0524t plus 1.377. And all of that second piece gets integrated from 0 to 12. Well, what we end up with here is everything's back in t. Instead of having 2 of these integrating both from 0 to 12, I'm going to opt to make it 3.121t minus this quantity, 2.399 divided by 0.524, cosine of 0.524t plus 1.377, all of that then integrating from 0 to 12. So I think you know the rule by now, the statement we have to do here. We're going to put 12 in here, and we're going to put 0 in here. So if I go through and look at f of 12 minus f of 0, I'm going to come down to, and I'm going to, let's see if I can get all this squeezed in here, 3.121 times 12 minus this fraction times the cosine of 0.524 times 12 plus 1.377, okay, minus, and if I put 0 in this first term, it's going to be 0 minus 2.399 divided by 0.524 times the cosine. And if I put 0 in here, I just have the cosine of 1.377. And so I need to now just come up with a numerical value, and I'm going to pause this for a moment. I'm going to double check my answer while you do the same thing. Okay. Did you get an answer of approximately, and if you paused it and worked on it, I did it both ways. I expanded this, and then I also went back and used the integration from 0 to 12, just to double check, of my R of t. Now remember, I have already defined R of t as f1 of x, so that made it simple to use that command. But both ways, we come up with 37.47 inches. Now, again, what does that represent? Well, it's the approximate normal annual rainfall. If we add up all the rain they get in each month, the average or the normal rainfall for each month, and for 12 months, and we add it up, we should have 37.47 inches of rain. Okay. Now, this may seem like, well, that's an awful long way to go for just doing the function 12 times, putting in a 1 through 12, and then adding those up. Granted, it might appear to be easier that way, but again, if you had more than 12, if you had 1,200, or you wanted to find it over a longer period of time, like 6 years, you wouldn't want to have to go through 72 iterations of that, and this would help you. Okay, our third and last part of this then is to look at the approximate the average monthly rainfall during the months of October, November, and December. So if we're going to find the approximate average rainfall for 3 months, well, we're going to, let's think of it as an integration now. We're not going to integrate from 0 to 12. Instead, we want to know what will the months be. So we're going to look at a total of 9 to 12, and this would be our derivative, or the integral rather, of the function r of t dt, but we're wanting to find the average, and this would find the total rainfall for 3 months. Remember, it's an accumulation, it's a summation. And so we take the sum of all of that and divide by 3, and so 1/3 would then be our value. If you're looking at that, what we would do in our work we have back here then is once we have found the antiderivative, we would then just use from f of 12 minus f of 9. And we use the very same work we have here, and we would come up with 1/3 times 13, or approximately 4.33 inches is the average monthly rainfall for those 3 months. Okay, well that concludes all of the work we're going to cover in this semester. I look forward to seeing you on the final. If you have any questions, don't hesitate to email me. Even though I may be out of the state, I still will be getting on to my email and answering questions as best I can. So please do that. I will also remind you that there are some course comment sheets that you are welcome to fill out. The course comment sheets, I have put them in Math Lab. You need to ask Mrs. Diltz for those. She will help you with filling those out and getting them into the proper envelope. I will say, though, that since I am, the purpose of these comment sheets is for you to have a chance to communicate information that would improve the class for that instructor. Since I'm retiring after next semester, these really will not, really don't have the same benefit. But for those students who feel the need to make comments, you're welcome to do so. I have made it a practice not to read anonymous comments sent by students, but instead I welcome your comments, and I welcome your comments to me directly. I know most students feel more comfortable directing comments after they feel secure in the grade. So, you know, sometime after January 1st, I welcome your comments. You may email me directly with those. Again, the purpose of the official course comment sheets really does not apply in my case, but you're welcome to fill those out. Please go to Math Lab. Check the Math Lab hours. It will not be open during finals week, so you do need to get in before the end of Math Lab this week. So I will see you on the finals for the final quiz during finals week. Oh, one more thing. I have made sure that there are homework problems for section 5.5B on WebAssign, so you can look at those and work on those. Okay, well, good luck with everything, and I'll see you next week.